You ready for the dance lesson? Or let the baby rip. So what you do is you unload your probe so it sits down. Just give it a test. Listen to the click. If it doesn't click, pull it down and up it in so nothing's stopping it. You're happy there. You need to do a home, and the equivalent code for that is G28. So we're home. The printer knows where it is. Probe is down. You've entered in those dimensions that it knows that the probe to be centered has to move so much that way, that way. It then can do the probing. Then once it's done probing, it knows where the center of the cap screw is. It then comes above it, goes down, touches, and then starts to lower itself until the Allen key is in the home lock position. It will then move up a certain distance. So that's what's supposed to happen. And if it's the first time for you, you hope it's going to happen. So we just do a G29. You can add a button onto the pronto face near the little table area there. You'll see this little plus tab, little plus button. Click on that and it will open, and you can type in G29 there and call it, whatever name you want to give it, homing, probing, whatever, blah blah blah. Save it, colour, and then we'll sit there. So each time you want to do it, you can do it, but I would get it right first, test it and adjust it, because we have to adjust it still to get it going. So now we hit the send and hope that all our measurements are right. 3, 2, 1. There it goes to wipe the, then it goes down. Trigger. Here she is dancing. And as it's happening, those measurements are being fed to the display. It's a nice sound. It's the best sound you'll hear because it's working. Now it's going back. Pushed up, there it is. Now, what you have to do, you're doing great. No, we're not there yet. And then what you have to do is do a G1, X0, Y0. And hit that. Remember our friend? It thinks it's there, but it's not. G1, I always leave half the code, half there. Z, G10. Remember our little tapered ruler, friend? Just slide it in underneath. Mine's spot on because I've rehearsed this. You wouldn't think so, but I have. When I done it, it was 8.2. So there was a variation in the height. So remember those measurements we had? What you have to do is you have to get it so as when it comes back to the correct position, it is at the right height. You have to change that. But before we move on to that, here is the recording, the data logging of the bed position and their height. Then it subtracts differences. And it shows you what it is. Now, you'll need to do several probes before you get this right. And all what I did is just open up a normal notepad and I called it probe test results and the date. With anything in this column, you can just highlight it, drag and copy and paste, which I did. So I put it in, down the bottom, I worked out the difference. And the range was minus 1.21 millimetre to minus 0.6, a difference of 0.61 millimetre on the table. Now, there can be several reasons for that. The table could be tilting up, tilting down, this sort of thing, curved or dished, all that sort of stuff. But then I waited a minute and I done the second probe, and there was a difference of 0.09 from the first. I just waited a minute and done it. The idea is you want the center of the bed when it's probed to read 0. It can tilt that way or that way or that way or that way, but that needs to be 0. And how do you get that from 0? This height you now measured here, little friend, it's supposed to be 10 millimetre and it's 8.2 or whatever happens to be. You subtract that from the 10 millimetre, that is, so 1.6 was mine. So then you have to go into your file, your config file, and at that auto probe height, your Z dimension probe offset, that Z dimension, define Z probe offset from extruder, test after probing M114 with nozzle and paper to be 0. So that is the setting. I originally had 7 something or other, subtracted 1.6, done that, done another test, found out, okay, that might be 0.5 a millimetre out. So I think it took about 4 probes. So here's a probe offset that I did, and then in the end it was, center was 0 and it was 0.1. When that happens, when you go down to 5 mil, 0 is with the paper. So when you go down to 5 mil, it should just slide underneath, go 0.1, and it should just touch. So that's where you chase, you make an adjustment, you come back and chase, make an adjustment and chase. 4 or 5 probes, no problem. Trouble is, Again, you then have to check your Z height, home. So go up, home, come down, check that it is 0 with the paper underneath it. If it's not, go back to the Z home height, change that, come back, do another probe, because don't forget the Z0 is different, so those little figures might be different. Do another probe, get it adjusted till it's 0, check the height, so bigger circles start to get smaller ones. Then after about 4 or 5 probes, you know what you're doing, and you can go and test it and be happy. So if I now do a home, deploy the probe, do another home, do a G29, that's it wiping, comes back, does a stance, that's a Delta printing stance. So once you've got it done right, I'll go home. Copy that last lot of figures, the differences. Copy those, open up a new notepad, paste them there, so you just got that. Save it as differences, whatever you like. Then open up Excel, open up that text file as a space delimited file, and it'll come up, it'll load them up. Then just go up into the insert area graph, highlight your text, and then you can just draw the area graph, and then you have a visual representation of the actual profile of your table. Flat is a 0 point, so I can see here in the front that that's only 0.1 of a millimetre each of those steps. So I can see here that I couldn't say the table was tilted because it isn't bigger down there. It dips in, but it's got a bit of a zigzag to it. And the other end, well, this end here may taper, but that's a lot flatter there. Here runs up and down. This one runs higher that end and then higher on that end, but shallower in the middle. This one dips and then there's a sharp drop up the end here. This one goes to high to low. So you can get a visualization of your table profile, and the maximum there is 0.4. If I go back to the original file, so it varies from minus 0.3, so some parts of the table are below the center, to 0.47, so half a mil one area, and the difference is 0.77. When I first done a probe, the difference was 6.1. So the table hasn't moved, but it's increased 0.16 of the variation. That can be, these probes are wobbly, can be hitting and drag and not triggering. So 0.7 of a millimetre variance. Good or bad? I think I'll wait till I do some printing to decide. As you saw in the profile, I can say I'll adjust this down 0.1 of a millimetre, but what's it going to affect when you've got a profile like that? So at the moment I'm happy, and if we go into next page, they tell you how to send it. If your width is out, so if it's supposed to be from the centre and you move across, then go back out, you have to adjust your delta rod dimension. But some people like to do that when they're printing, and they can get a vernier caliper on and measure, okay, that's 0.5 of a millimetre. Looking here, a bit of paper, it's not that accurate. So you're actually ready now to actually print. Yep, you're ready to print. But the calibration hasn't started, it's just now you're starting to work with hot things to calibrate. So I'll leave the rest of the journey for that with you. I can show you how to do it and all that, but that's just standard now. That's nothing unique. My method will be the same as everyone else's method. So this was a journey to show you how to assemble the Syntron printer, overcome all the obstacles, why there were problems there, how you can fix them, how you can improve it, what ideas you can to redesign your own, and what I will be doing is, once it's calibrated with the printing, I'll be printing up new parts, cover and all that, and that will be added to the front of the introduction video, which I haven't done yet. I have to finish this thing and then show you what it looks like at the end. So as always, thanks for watching, and subscribe if you like, tell your friends. See you next time.